And the last one, similar question. X plus 5 to the fourth and x minus 3. So if I have x plus 5 equals 0, subtract 5 on each side, I get x equals minus 5. But there's 4 of them. So x equals minus 5 with a multiplicity of 4. And then this one will be x minus 3 equals 0, or x is equal to positive 3 with a multiplicity of 1. All right, hopefully that helps you with that video or those questions. Same thing here. Either minus 4 is 0, or x plus 3 is 0, or x plus 3 is 0, or x plus 3 is 0, or x minus 4 is 0. So this is a true false statement, so that doesn't work. Here I'll get x equals minus 3, 3 of them. So I have x equals minus 3 with a multiplicity of 3, because there's 3, and this one x equals 4. Okay, that is that one. Here's another question. Find the zeros of this polynomial and state multiplicity. Now here, this is already in factored form. So if it's in factored form, let me set this equal to 0. So 0 is equal to negative 7 times x minus 1 to the fourth times x plus 2 squared times x cubed. Okay, so I can go and I can set each one of these factors equal to 0. So either negative 7 is equal to 0, or x minus 1 is equal to 0. Now there's 4 of those. So I'll just put them one under each other. And then I've got x plus 2 is 0, and there's 2 of those. And then there's 3 x's. So x equals 0, or x equals 0, or x equals 0. So I don't have to graph this, but they say, what are the zeros? So the zeros, this first one, minus 7 equals 0, that's a false statement. So that one won't count. But this one will count. Each one of these I can solve to x equals 1. There'll be 4 of them. And so one of the zeros is x is equal to 1, and it has a multiplicity of 4. Multiplicity of 4. This one I'd have x equals minus 2, and there's 2 of them, so I'd have negative 2 with a multiplicity of 2. And then this one I'd have 0, x equals 0, with a multiplicity of 3. And the rest of the questions, I think, all right, here's some questions on finding zeros of polynomial functions. First one, I have a function looks like this one. I could graph that, and that would show me where the zeros are, which is probably a good idea, but mathematically I want to show as well. In Math 32, with a function like that, I indicated that you can always solve these or find the zeros by group factoring. So let's group these two and group those two. So the first two I can take out an x squared. That leaves me with x plus 12. Out of the next two, I can't really take anything, but I can always take out a 1. If there's a minus here, I always take out a negative 1. Okay, so minus x minus a negative 1 would be positive x. A negative 12 divided by a negative 1 would be a positive 12. So now when I look, this term and this term both have an x plus 12. So I can factor that out, and that leaves me with x squared minus 1. And this is a difference of squares, so I can factor that to x minus 1, x plus 1, and an x plus 12. Okay, so if I'm wanting to determine the zeros of that, then I would set the function equal to 0, because that's what on a graph anywhere here along the x-axis, that's when y is equal to 0. And so I want to know when y is equal to 0. So now I can use the 0 property that says if I'm multiplying things to get 0, one of them has to be 0. So either x plus 12 is 0, or x minus 1 is 0, or x plus 1 is 0. And I'll solve each of those equations. So I'll subtract 12 on each side, give me a negative 12. I'll add 1, and I'll subtract 1. So my three zeros are a negative 12, I'll graph that so it's over here somewhere. -1 and a +1. This is a cubic, so it starts low and ends high. So the graph will go like this. Something like that. Now here they say, what is the smallest zero? So that would be this one. This will be the smallest. Then this will be the middle one, and +1 will be the largest one. They say, what are the multiplicities? There's only one of each of them, and so they'll all have multiplicity of 1. So the smallest zero is -12, has multiplicity of 1. Then they'll ask you the next questions. Okay.